So again, work in the physics sense is equal to force times distance. But that equation only works if it's the very same force everywhere. And we have forces that we model that way, like gravity is pretty much the same everywhere. But how can we treat forces which are not constant? Forces which change their strength depending on where we're at. Forces of magnetism, forces of wind, and so on. Mechanical forces. Well, let's say that our object is going to move along the x-axis. For right now, we're just working in one dimension to keep things simple enough. And for every point between, let's say, coordinates A and B, there will be a differing amount of force. We'll call it f of x for force. And it makes sense that this force function should be continuous. Probably doesn't have jumps or infinite discontinuities and holes in it. Probably not for, at least not for Newtonian physics. Okie dokie. So what we're gonna do is we're gonna try to estimate the amount of force for subintervals of the interval from A to B. Well, why are we doing this? So I could estimate, maybe take an average amount of force and multiply it across that whole distance to get some idea of the work required. That'd be a decent estimate. But it'd still just be an estimate. How could I make that estimate better is if I chop up my interval into several pieces, and each of those pieces could have potentially a different amount of force in that region. Maybe my force over here is very strong, my force over here is very weak, but in the end, I can approximate the amount of work to push my object against the hard force, push my object against the softer force, put that together, and that's the total amount of work I spent. So on each of my intervals, I'm just going to take some sample point, xi, and I'm going to calculate what is the amount of force at exactly coordinate xi, or xi star if you prefer. Well, if I know the amount of force at coordinate xi, and if I know the width of that interval, well, my amount of work for just that one region is going to be f of xi times, well, my good old delta x, my width of my intervals. So adding all of them up, my sigma notation is just standing for a bunch of plus signs that I don't want to write. If I add up n different pieces, all of them look like a force times a distance. Why, that must be work that I am calculating. And like a broken record, my approximation gets better the more subintervals that I take. And in the limit as n goes to infinity, this Riemann sum is going to become an integral, which we know how to calculate. So now my force, my function f of x, is being evaluated at all the different points between x equals a and x equals b. And when I integrate that up, I get the amount of work exerted to move my object from A to B. Let's actually calculate.